Middle school is a time when young adolescents explore new ways of expressing themselves and new ways of interacting with peers. Skilled middle school teachers learn to respect and work with these transitions as they engage students in challenging science activity. In this series of videos, we visit the classroom of one such teacher, Anna, as she helps her students learn to work with each other as they develop and refine science ideas. The subject matter for the unit we show is how energy influences changes in states of matter. We begin by having Anna introduce us to her teaching context and to her students. You'll hear distinct themes as she describes the work of teaching. One is that teaching is about working with students' ideas rather than merely covering curriculum. And the other is that students need structured guidance in how to participate in science-specific forms of activity and talk with their peers.
Anna, you're in your second year of teaching middle school. Can you tell us a little bit about your school and your kids?
My school is located in a weird part of town, so it's not technically a part of a city. It's in unincorporated county land. So what that ends up meaning is that it's like an urban neighborhood, but it doesn't have the supports that a typical urban setting might have in terms of social services, school levies, things like that. So if you go back long enough, it used to be a predominantly white suburb, so it's laid out like a suburb, but a lot of the people that used to live there, some still live there, but a lot of people have moved back to the city or somewhere else, and it's been replaced. A lot of the housing has been replaced by low-income housing. There's a lot of Section 8 type housing and just a general kind of immigrant population that lives there now. So it's a pretty diverse area. The majority of kids are Latino, and the majority is about 30%. So that's kind of sets an image of the variety, I suppose, in terms of ethnicity.
So tell me about the class that you teach.
This year I'm teaching 7th grade science, which at our school now is a semester of chemistry and a semester of biology. So last year, my first year, I taught 8th grade. So next year I will go back to 8th grade. So I'll follow these students on to their 8th grade year, which will be astronomy, earth science, and physics.
When you think about what you want your kids to really know and be able to do by the end of the school year, other than, of course, understanding a lot of scientific concepts, what are some things that you have in mind as goals for your kids?
Well, I have kind of two sets of goals, because one of my sets of goals is a 2-year goal, because I knew I would have these students for 2 years. So in terms of the 7th grade year, which currently is the first science these students have had, the first real continuous science, my 7th grade main goal was just to get them comfortable sharing ideas about science. So, so not just able to share, but also feel like they are a contributor to that particular community. So the main 7th grade goal is that when kids leave 7th grade science, they think of science as something that they can be a participant in. Within that, there's also some sub goals or some things that come along with it, like getting them comfortable talking about science to, first maybe to someone that they're comfortable with, and then maybe later on in the year to anybody, to a strange adult that they don't know that comes into the classroom and is observing and asking them questions that they feel like, even to someone that they're not comfortable with, they can still say something that could be viewed as important, to have confidence in those ideas.
So when you say talking about science in your classroom, what counts as about science is a little bit different than in a traditional classroom.
Yeah.
What counts for a contribution that's about science in your classroom?
Almost anything. I think if I had to summarize it, I would say that my main goal is to get them to sort of be able to come up with ideas and be comfortable saying, I just had this idea, I'm going to lay it out as science and have that count. There's also when you look at a question and you can't come up with something, you're stuck. Being able to go somewhere and use something else like a textbook or a video or a lab or anything really as sort of a source of evidence. So there's I guess really what the main goal, the original goal that I told you about was trusting or learning to value the kid valuing their brain as a source of evidence. So as a source of science knowledge, but then also learning to use these other sources that exist. So those might be within school, they might be within my class, they might be within another class, they might be outside of school, they might be something they see at Starbucks over the weekend, which is an example that happened this year. So another thing that I try to get kids to do when they have run out of, I guess what you could call self-ideas, is tapping into other people's ideas or experiences, specifically other kids. So that might look like a question that's framed that day that has a kid's name attached to it, or it might actually be sending a kid over to talk to another kid and guiding that, saying something like, hey Jimmy, if you go talk to Casey, he has some really great ideas about heat that I think you should hear. Ask him blah, blah, blah. Or ask him to explain his ideas about, and then you fill in the blank. So there'd be keywords that I had already discussed with that other student so that they're set up to have a conversation already.
So if I came into your classroom multiple times throughout the year, I would probably see similar kinds of practices that you engage in, or similar kind of hallmarks of what your kids are doing. Can you talk about 2 or 3 things that would characterize your teaching?
Yeah, I think that every unit has a loop that is predictable, and it always starts and ends in a very similar way. So we always start with a day or 2 days, or sometimes even 3 days, depending on how complicated it is, with something that is puzzling. So we have had a lab where we distilled soda, and that was more than 1 day. And we have had me telling a story about the lake next door and how it's polluted. So we try to find something to focus on, some puzzling thing that kids are going to need to figure out. So they're going to need to spend time learning about different parts of whatever that idea is, and they're going to need to put ideas together. So it's something that has to have multiple layers. Then they need to record those ideas. So that's how we start. We ask them what they think, and then make them record those ideas in a written way, a model way, some type of way that gets what's up here down on paper so we can look at it. And the reason that we do that is because the next thing that we try to do is we try to always come back and revise those ideas. So depending on the structure of the unit, I'll always build in maybe 1 or 2 days that are strictly about going back and saying, stop, what have we learned? Look at what we wrote down before. How can we modify that, or how can we revise it, add details, change ideas that now we know aren't correct or aren't supported? Do we have new questions? But I'm finding now at the end of the year that that's just happening more organically anyway. Students are actually asking for those models that are kept in this box over here so that they can change something, right? So it's becoming less and less of a, now we're going to write this on this Post-it and do this, and they're starting to actually modify things as they go. So those are the 2 main things, but then none of that would even, in my mind, none of that would even really matter if we didn't do the last piece that you always see, which is some kind of group work about those models that have been modified and messed with and marked up and all sorts of crazy. So at the end of the unit, we always come back and there's some part of that initial question that we have to explain or model in a different way that requires kids to work together. And that always happens if I give an individual assessment, which I don't always do. Sometimes I assess kids based on their contribution to that group project or group poster or whatever it is. But that always comes before the individual assessment, if there is one at the end of that unit. So that's sort of the cycle. We share ideas, we record ideas, we revise ideas, and then we try at the end to just stop and put together everything that we've learned in a collaborative way. And that's a key piece, is that they have to work together.
From what you're saying, it sounds like one of the big features of your classroom instruction is for kids to work on their ideas or work with their ideas towards a pretty rigorous explanation in science. And from being in your classroom, I have seen records of kids thinking, different kinds of records, all around the room. Your walls are filled with records of kids thinking. So what function do those have in your teaching?
Well, I suppose there are two different sort of classes of function, because like I've said before, the 7th grade year to me is a lot about building kids up as scientists, as well as sort of teaching them content. So part of that is validating ideas. Here's something you said, it's on the wall, that makes it important. So somebody told me once, if your teacher writes something down, you know it's important, right? I think they told me that in college. And so whenever I get a kid idea that I think might not be taken as important, I try to write it down. Something that's happened a lot this year is we've started making checklists or lists of ideas on this easel that I have, and that's what a lot of what you'll see in my classroom right now is, are pages from that easel where we've needed to stop and do this, or we've needed to make a list of what sexual reproduction is, or whatever it is. It's just a snapshot in time of what they're saying, their words, and so you put it up, and so that part of that is, it validates their ideas, right? But then also, there's this other piece that they are middle schoolers, so their attention span is, relatively short compared to an adult. And so it's a great reference for them to have.
Yeah.
And we really try to do things that are cross-unit. So sometimes we might be teaching a unit on ecology, and we might need information from the cell unit or the what is alive unit. And there we have it on our wall. So it's a nice way to encourage them to cross-cut unit stuff, especially when it really matters. I mean, even right now we're finishing the year with ecology, and the concept of heat came up again. And on my wall I have a poster that says heat is, and there's a list of things, of analogies they came up with, like zombie tag, cause and effect, dominoes. Dominoes was a big one. And so all they have to do is turn and look and say, oh, that's right, that's what heat is. And it brings back instantly a lot, as opposed to just saying, remember when we did this? So there's sort of two functions, I would say. The validating piece, which is sort of present in everything, and then giving students another source of evidence that ultimately is really just their ideas or their classmates' ideas in a different way that I think they treat as gold because it's what the teacher wrote, So it's sort of playing on that a little bit.
So Anna, thank you so much for letting us come into your classroom this year, bringing cameras in, getting up close to you and your kids, and it was a joy for us to be in your classroom, and we thank you for making your teaching public in a way that it's not often made public, but it's for a good cause.
I agree.
For the improvement of teaching. Thank you.